So in this problem, we're going to use the principle of impulse and momentum in order to solve this problem. So here we have two vehicles crashing together. So this is the before and this is the after. So as they're headed towards each other, the motorcycle traveling at a speed of 30 meters per second, so in this direction 30, and it collides head on with another car that's traveling at a speed of 20 meters per second. Now the mass of the motorcycle is 800 kilos, whilst the mass of the car is 1000 kilos. Now after the collision, the two vehicles separate, the speed of the motorcycle is reduced to 10 and its direction is reversed. The masses stay the same and we don't know which direction this goes. So the principle of conservation of momentum basically states that the sum of the momentum before the collision is equal to the sum of the momentum after the collision. So before the collision, we have the motorcycle's momentum and the car's momentum. Now always pick right as positive in these situations when you're using this equation. So we're going to have the mass of the motorcycle plus the speed of the motorcycle, which is positive 30, since it's going to the right, and we always pick right as positive in these situations, plus the mass of the car multiplied by the speed of the car. Now since the speed of the car is in reverse or opposite to that, it's going to be minus 20. This is equal to the momentum after the collision. So the masses remain the same. So starting with the motorcycle, we know the speed is reversed, negative, and it's 10. Plus the mass of the car, which is 1000, multiplied by the speed. We don't know what happens to the car. This will tell us if it's positive or negative. 8 times 3 is 24, and then you have 3 zeros, so 24,000, minus 2 times 1 is 2, and you have 4 zeros, so 20,000 is equal to, similar here, minus 8,000 plus 1,000 V. So what we're going to do is we're going to find the difference here, which is 4,000 is equal to minus 8,000 plus 1,000 V. Now if you move this to this side, it becomes 8,000 plus 4,000, which is 12,000, equals 1,000 V. Divide both sides by 1,000. Therefore, the velocity of the car after the collision is positive 12 meters per second. So it actually goes to the right with a speed of 12 meters per second. So in this problem, part B and C, we're asked to find the magnitude of the impulse that one vehicle exerts on the other. Now the equation for impulse is I is equal to mv minus u, or in other words the change in momentum. The other equation for impulse was I is equal to integration of force with respect to time, but we only use that one when we have a force. Here we have no forces. So therefore we're going to go ahead and use this equation here. Now first of all, part B asks for the impulse of the motorcycle on the car. So when the motorcycle crashed onto the car felt a force hitting it like this. That force multiplied by time or integrated with respect to time gives you the impulse. So this is the direction of the impulse here. Let's go ahead and use this equation. Motorcycle on the car means you model the car. So I is equal to the mass of the car, which in this case is 1,000 kilograms, multiplied by the final speed of the car, which if you recall from the last part of the question was 12. It was 12 this way, so positive 12, minus, now if you look at the initial speed of the car, it's 20 meters per second this way, so it's minus 20. 12 minus 20 becomes a plus, so it becomes 32. 32 multiplied by 1,000 is equal to 32,000. So 32,000 Newton second, which is the units of impulse. Now let's go ahead and do the part C. Part C wants the magnitude of the impulse of the car on the motorcycle. So you model the motorcycle. So same equation again. Mass of the motorcycle is 800. From the previous part and from the actual question, the final speed of the motorcycle is 10 meters per second and its direction was reversed, so negative 10, minus the initial speed of the motorcycle, which was 30. Now, once you plug those values in, minus 10 minus 30 is minus 40, multiplied by 800. 8 times 4 is 32, you have a minus as well, so minus 32, and you have 3 zeros, so 32,000 Newton second. These two values are always the same, except they have an opposite sign. So if you've got an answer where these two are not the same, that means you have done something incorrect. So make sure you go back and check your working out. These two should be the same, but have opposite signs. So in this part of the problem, we're asked to find the loss in kinetic energy. So when these two vehicles collide, they lose energy. They have energy here, and after they collide, the energy is lost due to sound, heat, friction, these kinds of sources. Now, let's find the initial kinetic energy minus the final, gives us how much was lost in between. So kinetic energy is the energy of motion, and the equation for kinetic energy is half mv squared. So let's find the total kinetic energy before the collision. So for each vehicle, all we do is half the mass times the speed squared. Direction does not matter now, and the reason for that is because in this equation, velocity is a scalar, not a vector, because energy has no direction, it's a scalar. So it doesn't matter if it's positive or negative anymore. Plus the energy of the car, 1000 times 20 squared. That's the initial kinetic energy minus the final kinetic energy. It's that simple. Half 800 times 10 squared. Don't forget to square it, common mistake. Plus a half mass of the car times 12 squared. You go ahead and you plug these numbers in and you find the final value. So all this here make 560,000 joules minus all this make 112,000. So when you subtract these two, this will give you the change in kinetic energy, which in this particular case is equal to 448,000 joules, or 448 kilojoules.